All right, and welcome to Database Design Chat number 8. This time I'm going to talk about relational form. We're going to define what makes a table a table. And this is really foundational stuff. And I usually have rolled this in first normal form in my books. Next time I won't. You live and you learn, right? But this foundation of what a table is kind of an important thing to really understand where you're headed and what you're trying to do. So first, just a very brief introduction. It's been a while since I've done one of these. I'm Dr. SQL, and if you want my information, DRSQL. The easiest is my linktree./DRSQL. I've got all my links, and I've even got links to go to my not SQL stuff, my Disney, like you can see behind me, my Disney, my Dollywood writing and stuff. But all right, so what is a relational form? What does that mean? Well, tables have a certain specific design. And one of the first kind of thing to talk about is stuff that really fits SQL Server well. All data is structured in tables as rows and columns. You notice there's no variables, there's no setting files, there's no anything you can get to in SQL Server where it's not really a row or a column. What's even more interesting is if you look at the way they implement files, like the file table implementation, that actually is going to use a row and a column, and it fits that paradigm in all cases. Sometimes, things below the table might have more meaning, more below the columns. Like I may have a row that represents the entire football team, and each column may have all the players in the team in that row and columns. We're going to talk later about how maybe that's not the right way to implement things, but that is based on that's how it was. That's the very foundational of relational form. Now, a couple of other bits and pieces that are important. The order of the columns doesn't matter, and the order of the rows doesn't matter. If I do a select from the table and I get back 1, 2, 3, and the next time I get back 2, 3, 1, that's the same table. There's no order in sets. And I say the order of columns, if you add a new column to a table on one copy of a database, and then when you release it to production, say, and you don't have the exact same order of columns, that table is still foundationally the same thing. You're expected to request your rows and columns in the order you want them, not just let the structure of the table be your guide. Now, one of the things that is really kind of annoying about SQL Server and the relational model in and of itself is that all rows must have the same number of columns. Now, this isn't so bad when you're building the kind of applications we built for hundreds of years, right? I want to store the customer. And so they've got a first name, last name, middle name, address information, etc. So that's part of the base structure, is that all the rows have the same number of columns. One of the things, if you need that kind of flexible structure, you may not want to use the relational engine. Later in the topics, I'll talk about how to be more flexible than just every single instance of one of your things you're trying to model having the same number of columns. But the physical structures, when you do a select from table and you get back some rows, they always have a fixed structure. So you never have to question that. And finally, the thing that trips up a lot of us is no duplicate rows. I'll talk more about that in a few minutes, but that's the thing that you can actually have in SQL Server. You're not required to define uniqueness, though we will talk about why you almost always should. So uniqueness of rows is going to be controlled by keys. And a key is a set of columns. I have first name, last name, middle name. Maybe you want to think that's unique, or it's usually not. It's usually, we'll talk more about that in a later episode. But there's a lot of things that feel unique. What's the likelihood of having the same person with the same first name, last name, middle name working at the company? Well, it's very, very low, but it's not zero. So a key is a set of columns which must be unique, no matter what occurs. So an employee number. You're usually given an employee number. You have a social security number in America. How it's implemented, how this key is built is not only, we'll talk about later, we'll talk about indexing, we'll talk about the physical structures and things. But one of the things that I tried to hit on in the previous session where I talked about, how would my structures change for the cloud? One of the things to note there is that the relational engine is supposed to be magic, and we're supposed to just tell it, make this unique, give me some rows, give me some columns, here's some data, and it just does it for us. How it's implemented is not super important to your customer. What's important to your customer is that when you put some data in there and you want to get it back, you're able to fetch it. Because all data in a relational engine is accessed via two things. You have the key columns. I know the employee number. I know the state they live in and their driver's license number. And I know the name of one or more columns to address the values. I can go, give me the first name, last name, middle name of the customer whose employee number is X. So we have that. And that makes it very easy. That makes it very easy to fetch data. You don't really need to be technical oriented to be good at SQL. It helps when you're designing it. It helps when you're writing really, really big, complicated queries. And some of the queries you may write will be thousands of lines long. So not everything can be done by a non-technical person, but the core idea of the relational engine was that it would be accessible to everybody. And you wouldn't have to be, a super genius who can go to the bits and bytes and mess with things. You just write select star from table. And star is a shorthand for all of the columns. It's not something you should do in production data, but it's really good when you're doing ad hoc or one-time access. And once you know the name of the columns, you access them that way. You put them in the order you want. If the table changes, everything stays the same. Uniqueness is really complicated at its depth. Easy at the core, just make sure the two rows aren't the same. But it's a little bit more complicated as you get deeper, because it's not just that rows need to be physically unique from one another. One bit is different on each row. That is technically the definition of unique, but it is almost always something the user needs to know to be able to find something. I know I go back to the employee ID. I know that employee ID, I can find the user. I have some data about them. I can go searching. I know his name's Lewis, so we go searching and we go look at every single row on the table. It's like going through a phone book, looking through every single page in the phone book. For anybody who's, never heard of a phone book, it's a thing where you had all the phone numbers in it and the people's names. So hopefully most of you know what it at least is. But it's a complex topic. Uniqueness is more difficult than almost anything, because you really have to think about a lot of objects and a lot of what makes uniqueness. In fact, some of the later normal forms we'll get to will be all about uniqueness and how you really define what is something. But let's just talk practically first at this first early stages. This is part of performance. Once we know how people are going to access rows by name, by object, by structure, we can optimize their method of fetching the data. And it's something that it is just sort of built into the process if you do it right. Data is just built the same way. We know it's a table. We know it has columns. We know where to get it. We know that two rows don't have the same data or the same meaning. We know the database is still consistent if rows change physical locations. That ordering is really important, because if you add a clustered index, for example, to a table, that'll change the order of the rows. If you get rid of the clustered index, if you select it into another table and put it back in the same table, you may get different physical order, but the data itself is exactly the same. Separating this physical from logical being the way the user sees the data. Separating those two things from each other is really important. And what you're really going to care about, on one hand, is this logical thing. What matters to the customer. They need to be able to have customers and addresses, etc. They don't care if it's stored on SSDs. They don't care if you put it in the cloud. What they care is that their data is correct. So we care about consistency. If the physical location moves and that doesn't change anything, then that's great. All right, already said that. As an example, a lot of times when you're looking at someone's data, I was thinking as a consultant, but when you're looking at someone's data, and it could be your data, you will find something like this. You'll find a bunch of rows that have the exact same value in them. And all the columns, we'll cut that down to just one column here. There may be some columns that have like the last time this row was modified or when it was created, and those may be different. But we get in this situation. And you think, I know a little bit about SQL. I know they have this thing called an identity column. I'll add that to the table. Now they're unique, but the user has no idea what the difference here. So by definition, you've made physically them different, but you haven't made them logically different. So you have to go in and really think about what is it that identifies them. Then there'll be people who go to this level and they say, well, we'll make name and color unique. And by that, you can look for this value. Well, of course, black, brown, black, white. I mean, these are descriptive values that may or may not be useful to identifying this. If you're thinking, I think smoky is a smoky color, I can look that up. But usually that's not exactly what you're looking for. What you're looking for is, why are we storing this mascot? And how are we going to get back to this mascot when we need it? And in this case, we're going to add that. Now we know the smoky, that is the mascot for UT. We can get that. Give me the mascot of UT. And there may be multiple mascots for UT. I mean, there's a rifleman that's part of it. Old Daniel Boone hat wearing guy. There may be multiple mascots, and that's okay. And there also may be multiple people that play each mascot, and that table gets built, and that becomes more stuff that you have to model. But more on that later, obviously. All right, so now we have this table. We have our keys on mascot ID, which is referred to as a surrogate key. Talk more about this later, but a surrogate key stands in for the actual key that you are working with. And then the actual key that the customer cares about is name and school. All right, so now you want to find the mascot for UT, name Smokey, you got that. Now we can find out his color. We can find out any more details that you may want to put in there. Now, one of the things to really understand is I'll talk a bit about testing, and maybe I'll even get into testing sometime. But when you build something and you think about what is the most important things, make sure you test those most important things. So go back to that table, and that's the table that your customer is demanding, that it just has name or just has name and mascot ID. And you can't define uniqueness on it. Make sure in your testing code, in your unit testing, your customer testing, you make that table just a million rows with the same value in it, and let them look at that and go, why is this like this? I would never do this. Well, first off, you're a customer. You can't imagine the things you're going to do to me and to my sleep every time you make a mistake. But sometimes it's not customers. Sometimes it's automated processes that get out of hand and start making lots of extra rows. Some things you can't catch. I don't want to do too much into this. We're already running kind of long for a quick chat, but there are cases where that's okay. There's types of data where you may not be able to define uniqueness too detailed, but most tables you will be able to do that and capture the data in a way that the customer would not be confused by it if they go looking for a row. All right, so I'm going back to this correctness. correctness starts with proper structure, and that is always going to be the case. If you get the tables right, if you make sure that that data is unique, all that kind of stuff, it's going to make it not only proper, but it's going to improve your performance. Because our goal is to map these tables to the relational engine's needs. You know, always in common sense, it's everything you talk about can be taken too far, right? We can always go to a level that will drive your customer insane because they don't really care about it. Make sure it's always in common sense terms what the customer wants. Don't do your own thing. It's been probably a month since I've done one of these, so I want to make sure I just cover that again. All right. So if you have any questions, comment on my YouTube video, email me at drsequel@hotmail.com, message me on Twitter, contact me anywhere you find on Linktree. Even my Disney channel, I'll talk to you about SQL on my Disney channel all day long. If you ask a good enough question that stumps me or makes me want to talk about it, I'll add an episode and I'll reply directly. I hope it's been useful. It's good getting back after the holidays. I hope everyone had a great holiday. And I will see you next time. Bye-bye.